Okay, hi there. Today we are going to move on and talk about a new machine learning model, and that is decision tree. One of the reasons I like decision tree is it is one of the easiest model to interpret. Especially if you're presenting your machine learning models to non-technical people, and decision tree is one of the easiest machine learning model you can interpret the results and you can explain how it works. And by the way, for the k-nearest neighbor and the naive Bayes, those two are also considered to be the really basic and simple machine learning models. And sometimes I personally call them white box models because it is very clear and you can explain the concept and the technology behind the machine learning model to anyone. And I believe I can explain that to my grandma, and she should be able to get the point. Okay, so especially when you are presenting your work to the people who want to make sense of your machine learning model. However, you suspect they don't have enough technical background, and decision tree might be a good choice for you guys. uh, for decision tree, as the name suggests, we are just making the decisions based on a tree structure, right? So at the very beginning, we have a root, and on that root, we have to make the decision on whether we go to one side or the other side. And then when we go down, and then we have to do another if and else, and then depending on our choices, we go down again. So eventually, we start from the root, and then we will go down to the bottom. And at the bottom, and then it will give us a label saying this is the value, this is the label I'm gonna tag to the new test sample. Okay, so let's take a look on a toy dataset. So uh, let's assume that we are having a another person we are having another person that I have been playing, say, tennis with. Okay, so for this kind of person, uh, this person sometimes he comes and sometimes he doesn't want to come and play with me. So I keep a record of all the each of the days I ask this person. So including the temperature, the outlook, the humidity, the wind, whether it's windy or not, and eventually I want to predict whether this person is going to play or not on a specific day. Okay, so for this data set, of course, we can use the naive Bayes, but today we are going to try something different. So if we use all the available data and then we want to build a decision tree, and this is a decision tree may look like. So we start from the root, and on the root we test one condition and only one condition. And if that the condition outlook is sunny, I want to move down and check whether it is the humidity is high or not. Okay, whether the humidity is smaller or equal to 75 or greater than 75. Okay, and if the outlook is overcast, and then we have luck because it's going to be a yes guaranteed. And if the outlook is windy, and if the outlook is rain, and then I have to check whether it is windy or not. So on each of the leaf, okay, so we are going to have yes or no, and we will also have the number. So for example, this one, it is yes because there are four cases, and when the outlook is overcast, and then for those four cases, we all have yeses. And this one is a little bit tricky. So when it is sunny and then the humidity is higher than 75, there are three cases. So among those three cases, we have two no's and one yes. So in this case, since no is a majority, for this leaf, we are gonna say it is a no. Okay, and this is just a conceptual decision tree. And the real decision tree, as we are going to see later, it doesn't work exactly like this. But this example will give you a good idea on how does a decision tree work. So here are some of the key terms. So for decision tree, we are going to have a lot of the nodes. So for each of the node, and it may have a corresponding branching rules. So for example, like this one, if we are on this node, we are going to check one attribute, and then there can be it seems that we can have two or even three branches. In this case, we check one property, and then depending on the result, we will go down, and if it will bring us down to another node or a leaf. Okay, so what is a leaf? So a leaf is the end of the decision tree. So when we are at a leaf, we don't have to make even more decisions. Instead, the decision tree will give us a label saying if you have go all the way down to here, and then this is the label for you. And the next thing is the impurity. So we are gonna talk more about the impurity later. So the concept of the impurity is if we reach a node and it is 100% pure, 100% of one label. For example, like this one, yes. Okay, in this case, well, it is a pure leaf already. So since all the four samples are yes, so when we reach here, this leaf will be yes, guaranteed. So for the impurity, it will help us build the tree, and then for each of the step, we are going to decide on which attribute are we going to split the tree. Okay, so the impurity is the matter to help us make the decision on how to build a tree. And we will talk more about the impurity later in the next lecture. So let's see a very small example. So we import all the necessary packages, and then this is a data set of kyphosis. So kyphosis is a disease on the person's spine, and then if there a newly born baby has this kind of disease, and people can see that almost immediately. So when a newly born baby has this kind of disease, one of the choice that the doctors can make is, well, they can give the baby a surgery immediately or a few weeks after this baby is born. So in our kyphosis dataset, this is a dataset tracking after the spinal surgery, whether the kyphosis still present or the kyphosis is gone. Okay, so this is a dataset after the spinal surgery has already been made, and if we still see the kyphosis or not. And we will have the kyphosis, and this is the label we are going to make the predictions. So whether there's kyphosis present or it is absent. Okay, and the next one is age, and the age is the age of the person in months. So as I said, usually people tend to have this kind of surgery at the when a baby is still very young. And the number, that is the number of the vertebrae involved in the operation, and the start is so how many vertebrae are involved, and which is the number of the first vertebrae the surgery started. So those are the information, and we are going to use this information to predict whether the kyphosis still present after the surgery. So if we want to do a pair plot, and this is what you can see. So we have a lot more red dots than blue dots. So when you are seeing this kind of data set, you want to remind yourself, it seems that the data set is imbalanced. Okay, so when you're dealing with imbalanced data set, you have to be very cautious because you may have a misleading machine learning model, and eventually your result could be misleading as well. Okay, so after then we can do a train test split. We keep the kyphosis as the target column, and then for all the remaining features they are the X, and then we do the train test split. And after that, we want to make the decision tree classifier and then train our model. So finally, we make the prediction, and if we want to do the classification report and the confusion matrix, we can import both of them. So we make a classification report. It seems that the performance is just okay. It's not really impressive. Considering the size of the dataset, probably I would say that's acceptable. Okay, so I'm going to pause here. In the next video, we are going to talk about how we can visualize the decision tree.